Hello there! Introducing InvoiceBot. InvoiceBot is a free open source solution that adds Ethereum and one or more popular stablecoins as a payment option to any e-commerce website. Merchants don't need to pay an intermediary crypto payment service provider like BitPay if clients can pay directly on-chain. Those providers are useful for instantly cashing out cryptocurrency to dollars in your bank account when you don't want to risk sitting on cryptocurrency for any length of time. But that risk's eliminated if you get paid with a stablecoin. Stablecoins are proxies for US dollars that are represented on blockchain as tokens, and their value is pegged to the US dollar in a real bank account somewhere. InvoiceBot can support multiple stablecoins. In fact, any token that adheres to the ERC20 standard. Tether is the most well-known ERC20 compliant stablecoin, but there exists also USDC, also well-known, and there are also others out there. So let's take a look at the architecture of my solution. The first part of the solution is a smartphone app. I've written two examples of this, the Keymaster and Simplith. Both are on my GitHub page. And they use the Adelos QR exchange protocol to communicate with the web browser on the desktop. So my solution includes a web app, and that's made up of HTML, CSS, and JavaScript files that you can interact with directly through your smartphone, and that any desktop can be any computer connected to the internet. It doesn't have to be yours. It could be any potentially insecure, just any insecure computer, and the protocol will still do the right thing. So this is your website, and someone's using their web browser to connect to your web server. My web app is dependent upon some CGI scripts in the CGI bin directory, and underneath it all is a smart contract called InvoiceBot, and that lives on the Ethereum blockchain. Actually, my solution should work on any EVM compatible blockchain. So you might ask, why can't the app on the desktop talk directly to Ethereum? Why do we need this CGI stuff in the middle? And the answer is because of the way the web works. When you have a web app that loads on your browser, it can only talk to the web server it came from. It can't talk to any other servers on the internet like a peer-to-peer server on the Ethereum blockchain. It's not allowed to. And so that's basically how this is a decentralized application, or DApp. This is how it works. So I've developed this solution. I've posted the solution on GitHub, and I've rigged up a demo in my desktop environment. So I've got my own instance of Ethereum and my own web server, and I'm just going to show you in the next section what the solution actually looks like. Here I have a test environment with a web server and an Ethereum blockchain all running on my dev box. The user interface to InvoiceBot is a web page. Here's Firefox browser. I'm going to type in localhost as the site address since it's the same box, but in production localhost would be replaced with acme.com or whatever. I'm running on port 8000 instead of the normal HTTPS port, and the web page is invoice.html. Here's what it looks like when run without arguments. The page assumes no arguments means we want to create a new invoice. There's a CSS style sheet, so adopters can make it look pretty and make it look like part of adopter's overall site. But I've just left it a bit bare bones here. This blockchain ID is left as new value because the user can make a new invoice from here. When a new invoice is created, the blockchain smart contract will assign this unique number, and it's basically a hash of the parameters. Business ref is there to put a reference number for some other business system such as, QuickBooks or CRM with the accounting module. Below that, amount owing, that is amount still owing, because it can decrease over time as people make payments. So this is obviously the full amount when the invoice is created, and it can be in whole Ether or stablecoin dollar units. So we're expecting this will be possibly a decimal value in Ether or dollars. But we can have decimals in the user interface, but blockchain can't store floating point values, so we have to convert it to an integer when we actually store it. But here in the user interface, we just enter in how much ETH, how many dollars. Now, before I show how the commit process works, I'm going to rerun the page with parameters, just to show how this can load and pre-fill the fields. So let's give it a business ref. Brian, can be anything, it just has to be there. Amount is going to be some number of Ether, and we'll leave the currency as ETH. And all that does is just pre-populate the fields, no other functionality. I forgot to mention that the smart contract is written so that only the owner of the smart contract can create invoices. So this part of the demo is showing how I as the owner would use the app. Later on I will show you how an invoicee would use the app. But for now I'm just going to click on the commit button. And the app is going to publish an Ethereum transaction, but first it asks for my address so that it can fetch my transaction count from the blockchain. Transaction count's a value that has to be provided with every transaction, and it has to increment by 1 with each transaction published by the account. This is a mechanism to prevent replay attacks on the blockchain. So this page has appeared and it's asking for the Ethereum address. Now, I could type it directly, which, that would entail some risks because I would certainly make a mistake. Or I could cut and paste. But that would mean I would have some other app on my desktop, and I don't like having keys on my desktop. So instead, I think it's better to have my keys closer to me on my smartphone. And the way that I get my Ethereum address from the phone to the app is through this QR exchange. So I'm going to do an Adelos identification step. Just bear with me here. I'm going to scan and tell it to scan my response. It's a web app, so it has to ask permission for the camera. There I am. And now it wants me to sign a transaction. The transaction it wants me to sign is calling the InvoiceBot and saying, here's a new invoice, and here are the parameters, same I had in the previous screen. So using my Adelos app, I'm going to sign and scan the response. And done. So in this case, a transaction ID just comes back, and that's something I could look up on the blockchain later. The new transaction has that transaction ID, and that ID is available in the transactions event log. So we'll get to that later, but just for now we've created a new invoice, and we've done it by controlling the app on the desktop with the user's keys, which are held on the smartphone. So that's the most secure and easiest way that I've found to issue Ethereum transactions. This Ethereum transaction ID isn't all that useful, but having a value confirms that the transaction made it into the mempool and is waiting to be mined. So for now I'll just click OK. I'm going to create another invoice, but I'm going to do it in Tether this time. Brian2 will be my business reference. Oh, let's make it look like it belongs SAP, whatever. And we're going to make it for $1,000 in Tether stablecoin. The app already knows my Ethereum address and it's already looked up my nonce. So I don't have to do that step again, but I do have to sign the transaction. And in this case, the transaction is new invoice. There's the reference, 1,000 US dollars. So I'm just going to do that again quickly. All right, bring up my Simpleth app, scan the response, and there we go. So now I've created an invoice in Ether and an invoice in Tether. And I'll just click OK to make that go away. Now we're back at the new invoice screen. So how do we see the invoices that we've created? Well, the invoice ID is published in the Smart Contracts event log, so we can query the log and get a full history of all the invoice creation events that have ever happened. So I've created another page called invoices.html without parameters. So it just went to the blockchain and fetched all the events, and we've discovered 5 different invoices that have been created today. It's gathered the business reference, it's got the amount that the invoice was originally for, and the amount still outstanding. Now we haven't made any payments yet, and so the amounts and the owing amounts are the same, but in other tests later on we would see these amounts starting to differ. But the point of this page is, let's say you want to tell someone to pay the invoice. Well, we can create a URL using this invoice ID. I'll just copy that, and then we'll bring up the same invoice.html page, only this time we'll add a parameter ID equals that invoice ID. And so it's gone and fetched the invoice details from the blockchain. It was 1,000 Tether. There's our business reference. It gives you the option of paying the invoice, and it's figured out that it's Tether, and it's made the button look like Tether, so it's pre-configured the pay button. And then it's fetched all the events related to this specific invoice, and so far it's only had one, and that was the invoice creation event. Okay, I'm back after some bug fixes. Here's the invoices page again, and at the bottom there's the Tether invoice again that started out at 1,000 Tether and is now at 250. So I'll just click on it, and that comes from the blockchain. I made a 750 Tether payment to this invoice, leaving the balance of 250. You can see the events. There is a receipt event for the 750. Okay, so here's how the client would pay the apps, or pay the invoice using the app. So they would receive this URL by email or something, and they'd click on it, visit this page, and so they'd like to pay the balance. Before I click pay though, I want to mention what the app's going to do. I've reloaded the page, and so it's going to ask for my Ethereum address again, and so we'll go through the identification step first. Then it's going to get my digital signature and make the transaction to call Tether's approve function. That'll authorize the InvoiceBot smart contract to take the payment from my balance in the Tether smart contract. And then the app, as a second transaction, is going to call the pay tokens function. We're going to create that transaction with a digital signature created here, and we're going to send that to the InvoiceBot smart contract. And within the function, the contract is going to take the approved amount from Tether and then hold that same amount in InvoiceBot. So here we go. Clicking pay. Have to identify myself first. All right. We're going to do it by QR exchange. and identify, beep, scan the response. It's going to have to ask for the camera. There we go. Okay, so now it knows who I am. Now let's make our payment. $250, pay. So first we have to approve the tokens to come from USDT and to go to InvoiceBot. So let's sign that. Beep. And the transaction went to the blockchain. And the next time, okay, now we have to call pay tokens on InvoiceBot, and we're going to tell it to take 250 tether from this account, which is our identified account. So let's do that. Okay, beep. And the transaction goes away. Great. So where does that leave this invoice? Let's go back to the invoices page and reload. And we can see it's gone to 0. And if we click on this again, we can see 0 owing. We can see the 2 receipts that add up to the $1,000 that the thing was originally created to be. And there was a paid in full event posted by the smart contract as well. So that's how someone would pay an invoice using keys on their phone. The user experience paying with Ether is simpler. I've received an email with this link in it, I verified it, now I'm going to paste it in the status bar, or in the address bar. So I'm going to pay this 1 Ether invoice. But when I click pay, first I'm going to have to do the identification step, and then the app is going to get my digital signature to call the pay Ether function on the smart contract. And in the transaction that we're going to send to the smart contract, we're going to include that 1 Ether payment. So at the end of all this, the smart contract is going to end up holding the 1,000 tether that I already paid through the previous parts of the demo, and now it's going to hold this 1 Ether as well. So here goes. Clicking pay. Oh, it says I got to do this first. Alright. QR exchange. Identification step. Here we go. Needs camera. Beep. And so now 1 ETH. We're going to pay. And this is the transaction we're going to sign. Sign it with the same key that I used to identify. Alright, done. So now if we click reload, let's take a look at what comes back. There's the amount owing. There's the receipt invoice and the amount in way, and an indication that it's been paid in full. So that's pretty simple. And that's my goal, to simplify how people interact with web apps and other apps that use the blockchain. Make it simpler and safer. At some point, the InvoiceBot owner is going to want to grab the assets held in the smart contract. And the smart contract provides 2 functions that only the owner can call. There's a sweep function to grab Ether and a sweep tokens function to grab stablecoin. The sweep would be a separate web page I'm not going to show now, but you can easily imagine it would work much like paying the invoice. There'd be a step to gather parameters, an identification, a digital signature, and off it goes. So for now, thank you for watching, and I hope there will be more to show in the future. Cheers.